it's 5 steps. The 5 steps are: 1, attack the client. Everyone is doing client-side attacks today. It's very fashionable. If you haven't solved even one exploit client-side, you're not a really good hacker, but that's not bad. So the first thing we are going to attack is the client. Then we attack the hypervisor. Here, hypervisor is not meant to be just the software layer, which actually does the virtualization, but also the supporting modules, the core supporting modules. What you do then, you attack the supporting modules, which are all those nice services which are laying around, opening ports in your infrastructure. Then the management console. And once you've done all of these, you get to the internal stuff. So you try to attack the local machines. So first thing first, the client side. In order to understand how we attack the client, we have to say a little bit more about the clients in the virtualization environment. We all started with binary clients. Very nice installation, which you couldn't run in your own computer. Then everyone moved to the web applications. So web application clients, which don't really work, apparently. Because now we are all back to binary clients again. So for VMware, you have the VI client, which is a Windows-only application. For Xen, you have a vCenter application, which once again is a Windows application, where there is also an open source Linux version, I think. So we have to attack binary clients. Can we do something with them? Yeah, likely. I would not have told to you about that other way. So I'm going to present you an attack which was disclosed more or less 1 year ago, but it's still working on any version of the VI client. In order to understand the attack, we have to see how the auto-update feature of VI client works. This is a schema reconstruction I did by sniffing the traffic. There is some weird stuff going on, so I'm not sure it's the proper process here, but that's what actually happens on my computer. Basically, when you try to do login, so you press login in your client, the first thing happening is that the client is requesting the server a client/clients.xml file, which is a description file which the server uses to say to the client, hello client, I am version 5, and this is my description. So I am version 5, this is my name, and all this stuff. It's presentation, and shaking. Then there are some API calls going on. Once again, the request for the clients.xml file, no clue why, and then the login. Okay, that's what happens, actually. Yeah, the interesting part, obviously, is the clients.xml file. Look what's inside. You have, well, some configuration stuff, the audio port, the version and the patch version that the server is declaring. It's declaring, so, hello, I'm version 3. What about you, client? Are you version 2? OK, then you showed how to update on that download URL. And please do download that file and run it on your local machine. So if that does ring any bell, I hope it does, you can obviously think to attack that stuff. That's exactly what I've done. I have developed a module which is called the VI Lurker. The VI Lurker is a client-side attack which assumes that you are able to do man-in-the-middle against the administrator, so you have to be in the same network. And this is one of the very good reasons to have the administrators sitting in a different network from the rest of the world, maybe like the consultants which are visiting your infrastructure, like happens every time. So the point is that almost no one is using trusted certificates. All this stuff, obviously, thanks God, runs on SSL. So it should be secure. The problem is that almost no one is installing trusted certificates on the remote servers. They're all using self-signed default certificates. So what happens is that a man-in-the-middle attacker can just change the certificate and serve a crafted XML file to the client, to the administrator. And the administrator will just run the update, get owned, and then you're screwed because you just lost your administrators. And if I can get your administrators, I get all the infrastructure. As a bonus info, keep in mind that that's why I say that not everyone is checking SSL. Old clients, like the server version 1, is not checking the SSL certificates. And you even have in other clients, like in the OpenXen client, you even have non-SSL connections. So it's not to be given for granted. This said, there is also no code signing, but the user gets a certificate warning. So this is the wrong certificate. The user can't tell there is something going on. Unfortunately, no one is using trusted certificates, so So let's see this attack. I'm going to use some videos here because the infrastructure which would be needed to run all this stuff is quite complicated, and for another good reason I'll tell you later. So I'm going to show you a video of the VI Larker attack working, hopefully, which is this one. I will zoom, don't worry. OK, so in this video, you have on the right side, left side, the victim, that is the VI client. As you might see, I'm running inside VMware itself. I'm leveraging Unity. On the other side, we have the attacker. You have the attacker using Metasploit console, so Vasto. What we are going to do is we are going to run the auxiliary Vasto VI Larker module. The only parameters we will be setting is the local port. We are going to use a standard payload, this one, the Meterpreter payload. Okay, so leveraging standard Metasploit feature. That's why using Metasploit is so cool. We'll set the local port. We'll set SSL to true. That's a must-have. And we'll launch the server. We'll launch the exploit. Then on the other side, we're going to connect to the vSphere client. We're already in man-in-the-middle position for this demo. So there is no need to do all the ERP stuff or the ARP stuff to get into man-in-the-middle. So what will happen is that, well, here we go. We get the certificate warning, so we get it. But obviously, the administrator will just see, go on with my work, stop working for today, and guess what's going to click? So the administrator now gets a pop-up asking him to run the installer. So do you want to run the installer, whatever it is, or you want to save the installer? No clue what the installer is all about. So what's going to happen here, as you can see, we have a log of a given client connecting to us and asking the clients.xml. Obviously, the administrator is going to say, oh, yeah, they have updated the server. Let me install. We create the exploit. We create the Metasploit payload, which is run. Then there is, once again, a pop-up. The vSphere client update package has been downloaded. Would you like to restart? Oh, no, we don't get to ask it for that. We just be notified that we have to restart the client. We say, OK. Now, I used a very lame plugin, a very lame payload. So what you will see is a Windows firewall pop-up. And of course, the administrator has just been owned. So now, we just uploaded the exploit. And it is just a matter of connecting with a multi-handler plugin, set the payload to the bind TCP payload we have been using, and connect to the remote host of the administrators. Once we connect, we use the sessions, open the session, and own. Game over. OK? So thank you. So, and you're not seeing the better part. So this is the clients.xml file and the VMware VI Larker attack. Client-side attacks, a lot of fun, but there is not really anything you can do if the administrator is going to accept the fake SSL certificate in the end. I mean, if you're stupid, you deserve it. But apart from that, you get another way to attack. The hypervisor step is, as I said, attacking the core components. In order to understand what the core components are, I shall give you a very short idea what VMware environments are all about. So a VMware.zip version. So what you have inside for VMware, now VMware will kill me about this, but let's just keep it short. You have some desktop products like the workstation, the player, which are today not very interesting from pen testing perspective. There will be in the future, I'm sure, more client-side attack, more Ionio attack, but for now, we're going to concentrate on server products, which are ESX, ESXi, which is now called Hypervisor, I believe, in the last release, and the VMware server-hosted product. This is what they call the hypervisor layer. That is the actual servers doing the virtualization. Then you also have a management node, which is the virtual center of vCenter, which is the management console, which you can use to manage all your deployment, your large deployment. This is all you pen testers have to know about the virtualization infrastructure, because those are the targets. So usually you just point to the target and shoot. So hacking the hypervisor layer is more or less as giving a direct hit to the virtualization solutions, because you are shooting where the actual virtualization happens. On this matter, there was a very nice exploit released last year, which I just ported to Vasto, so you only have one tool to remember. You don't have to download 1 gazillion tools. And it was the guest stealer, so I'm just saying to you that it's there, no meaning in explaining other people's stuff, but basically it was a path traversal which was discovered by Flick and Morehouse and presented last year. It was a path traversal in a core component of the hypervisor, let's say the hypervisor layer, but it's actually a network component. So once again, what you have to do is set Vasto toward an old outdated server and just run it, and you will be able to retrieve any file as the root user. So, of course, the shadow file or any non-running guest, because it would be locked otherwise. So it works on all the outdated ESXi server. This has been great news when it came out. They did a whole talk just on this exploit, which is great. It was great. However, I always felt that the most rewarding attacks are those attacking all those nice components all around the environment, because those are the ones which are more likely not to be updated, taken care of. You just deploy and forget what's going on those components. That's exactly the reason why I've been attacking them. So the next step will be attacking support components. What is a supporting component? Well, it is any non-core component which is more or less shipped by default, or you can expect to find almost every time in any installation. It's always interesting attacking external components because you can find all sorts of stuff inside them. So what I did is I started trying to find a way to get inside those components and probing them all. If you run a port scan on a vCenter server, you will find a lot of open ports, and for the better part, you won't have a clue what they are all about. There will be mostly HTTP, HTTPS ports doing some SOAP stuff, some weird stuff with web services. So quite a mess to get to attack and all this stuff. So basically, this attack, the attack I'm going to tell you about, I found it during a pen test, which was running out of time. So I had to find something quickly. So I started browsing to a local installation of vCenter. And what I found out is that there is a very interesting component in the vCenter installation, which is not installed by default, but you can expect to find it in any large installation, any worldwide installation. This component is the host update feature. It is the host update manager. Basically, it's a component which is responsible for deploying security patches on the remote ESXi host. So I loved the idea of being able to hack the patching component. That would be nice. So what I've done, I've researched the component, and it turns out that it is vulnerable to a directory traversal as well, because it runs an outdated version of Jetty, of an application server, which is distributed inside the application, inside the component. It's vulnerable to a bug which is more or less, I think, 1 year old or something like that. And it's actually easy to exploit. Unfortunately, this bug as well was not, this exploit as well was not available when I looked for that. When I tried to find it, I asked the Jetty team. I would not like to thank them because they didn't give me the proof of concept, so I had to reverse the code and find the exploit. So the magic string here is actually very simple. It's just an encoded question mark, which you can use. And you can download any file on the vCenter. Huzzah, we got it! No, unfortunately not. Why? Well, you're now reading any file on a Windows machine, because vCenter runs on a Windows machine. So you have a Windows box, and you can read any file as system, because this service runs as system. OK, what would you do? I accept any suggestions here. Any idea? You can read any file as system on a Windows machine. What do you do to own the box? Yeah, nice idea. That's what I thought. I just get the SAM file. Unfortunately, the only SAM file I could read was the backup one, and they changed the password. So, didn't work. OK, fine. Yeah, me too. There was really an horrible day. I found this exploit. I was like, I couldn't use that. So what I did is I tried to find another way to use this attack. OK, now follow me, because it's non-trivial. What I tried to do is I tried to find some way to get some information to own the vCenter. I was not interested in the server anymore. I didn't want the operating system now. I just wanted the virtualization server, the virtualization environment.